So this is part 2 of a set of 3 videos where I talk about the examiner's comments for C1 papers over the last few years and use them as a basis for a kind of overview of the module. So part 1 we talked about gases and molecules and some of the language, and now we're going to move on to some more specific details. Be very careful about the language that you use. Things are not light. They might be light compared to something else, but we're talking about the density. So metals, we're talking about metals that are low density. They're used because their density is low, so therefore we can use a lot of it and the mass will end up being low, but we talk about their density being low. And also be careful, and sometimes I know you want to hedge your bets a little bit and talk about things if you're not quite sure of them. Make sure you know about these little aspects of the syllabus that have come in, and they just a kind of add on at the end sometimes. Shape memory polymers. So we've learned about polymers. Now you just need to know about these specific ones called shape memory polymers. And biopolymers, so the use of biopolymers in bags. So these certain special types of polymers, we've got designer polymers, we've got smart polymers that are changed by an external stimulus. So if you've got light, temperature or other changes, then they respond to that. And you need to know these examples. Pause it here, have a look at the kind of plasters. We've got hydrogels and we've got shape memory polymers. So things that actually respond to some kind of stimulus, and then we use that response. So here we're talking about wound dressings that are tightened up. And again, so taking a topic further, we've got the idea of renewable and non-renewable fuels, and we've talked about plastics and the problems with plastics and how difficult they are to get rid of. They take hundreds, sometimes thousands of years to break down, and landfill sites fill up. We've looked at birds that have swallowed plastic and that's been in the sea. So what we're trying to do now is find plastics that are made that are biodegradable and they can be broken down more easily. But again, it's one of these topics where you have to think about the downsides to this. So think about food crops being replaced by other types of crops and so on. Have a look at these. It's likely to come up in a 6-mark question again. Ores, okay, just remember the definition of an ore is that it has to have enough metal there to make it economical to extract. That's the definition. It's not just about something that contains metal. It's got to have enough there that you can extract it and still make money from it. Remember with metals we've got to take into account this reactivity series. Carbon is the important one here. We use carbon to extract iron because it's more reactive than iron. We talked about the difference in reactivity, but if you're trying to extract something like aluminium, we can't use carbon because carbon is less reactive than aluminium. You are going to get a copy of this reactivity series on your data sheet. Make sure you know how to use it. Make sure you understand that if things are more reactive than carbon, then that's why we begin to use things like electrolysis instead. Cracking. Remember what cracking is and why we do it and how we do it, and remember the language involved. Cracking is something where we heat things, but remember it's a high temperature. We have to vaporize things so that they pass over a hot catalyst. So when students talked about cracking, they didn't always understand that it's to break down molecules and hydrocarbons. Remember, we've got long hydrocarbons that are useful for things like laying roads and stuff, a surface for a road, but we want the shorter ones, pentane, propene, ethene, the shorter ones that are used as fuels, and we can get more money for them. We can make polymers from them and so on. So learn these conditions, learn why we do it, and remember that we always get an alkane, but we will also get at least one alkene. And if they give you an equation where you have to complete it, you've just got to make sure you've got the same number of carbons on the left hand side as you do on the right hand side. As it is here, we've broken it into 3 different products, but we've still got 10 carbons on each side, and we've still got the correct number, 22 hydrogens. It's just there has to be at least one alkane and one alkene there. You know about testing for unsaturated hydrocarbons with bromine water. You've got to remember that this is orange and it goes colourless, and you've got to be able to actually say what this test shows and be able to describe it, as well as using the data that they might give you in a question. Oh, the fractional distillation of air, it's one that we've looked at, and remember there's another video about this if you want to watch it. It's really important that you take into account the state of the element. If it's solid, then that's going to have implications for the question. Number lines are my biggest hint for this. If you're trying to work out what state something is in at a certain temperature, if you draw a number line and you put the temperature and the boiling points and the melting points and what state they're in either side of that boiling and melting point, and what temperature you're at, you can see it visually. And remember, with this you need to know the percentages, you need to know how the atmosphere evolved to the percentages that we have today, and you need to know the uses for the gases. Hydration of ethanol, then, this is one that people get confused about. Make sure you're talking about hydration, not dehydration, so you're adding water to things, and don't describe one of the other processes we talk about in C1. So this comes into the ethanol section. There's two ways we can make ethanol. We can either ferment plants' sugars, or we can take ethene and add steam to it. So we need steam rather than water. And again, we've got pluses and minuses, whether it's renewable or non-renewable, whether it takes longer to produce, whether we can just keep going with it, there's no waste products. So all of these have to be taken into account.